Today we're going to present our project compilation of pick-and-place path creation method. A specific problem is the automatization of the process of placing bottles in the bottle box using ROS. So the first of all, we define the ZH to get the power kinematic for every joint. So with the homogeneous informations multiplying for every frame, we get the matrix of homogeneous transformation. And the expression we can see here. So for the inverse kinematic are beside.
Well, we are using a UR5 robot with a Reaper 85. This robot can load 5 kilograms, and this Reaper can open its fingers until 85 millimeters. That's very good for our application because our bottles has a radio la, have a radio which is 4 millimeters, so its diameter is 8 millimeters. So this is the trajectory that we want to achieve. First, from the home to the bottle, to the bottle to the home, and to the bottle to the box, and to the box to the home. Here we can see every trajectory.
So here is the graph we use in the inverse kinematic using the library robotics tools that they use the mathematical Newton rhapsody. So all the joints start in zeros and start move. In the velocity, we see that all the velocity starts in zero and ends in zero, and the same with acceleration, starting zero and ends with zero. So then, the graph from the bottle to the box are the same. The curves are also smooth. Finally, the graph from the box to the home, we see how all the joints go back to zero. Here is the simulations of using inverse kinematic, but you can see that R is in the wrong way because the inverse kinematic give us the wrong angles.
So for the presentation, we want to achieve the goal. So that's why we try an error method where you can watch our polynomial trajectories and joint velocities and accelerations from home to the bottle. Here we can watch the bottle to the wall to the box and box to home. Eh, First, we think that we were getting the wrong angle from the robotics toolbox library, but our presentation we noticed that the reference system is different between Arbis and Gazebo. That's why the arm goes to the wrong position. So we need to take this from to another when we want to achieve another goal. So as you can watch, the the arm is doing its job. So here we have a comparison as the joint 2, joint 3, joint 4 are very similar, but only the joint 1 and joint 5 are different. And the difference is p radian, which is 180 degrees. And a conclusion, well, we are using the inverse kinematic function from the robotics toolbox, but we think that it gives us the suboptimal or practical joints and we can achieve the exact Cartesian coordinates, but now we know that is the system, the reference system. So here our reference where we learn about this, That's all. Thank you.